everyone, welcome back to my channel. Thank you so much for joining me once again. So what I want to do in this video is I want to go through the basics of set theory notation and try and point out the key areas where students tend to make mistakes. So a set is any collection of objects. So it could be a shopping list or a file directory on your computer, or maybe even a list of your favorite movies. So for example, let's say the set of Batman movies which star Christian Bale form a set. And we'll give this set a name, we'll call it set B, B for Batman. So whenever we're talking about set B, we'll know that we're talking about this set of 3 Batman movies. So we want to be able to define sets from scratch. So let's look at the easiest way to do that. That's called the set roster notation. So here's our set B in set roster notation. So we can see that the set is enclosed in these curly brackets, and the individual elements of the set are separated by commas. So that's how we can spot set roster notation, the curly brackets plus the use of these commas to separate the elements. So occasionally you might see these 3 dots, which are called an ellipsis, when we see the set roster notation. So here's an example right here. The 3 dots mean that we skipped over a bunch of elements just to save space. So we can really only use this technique when it's obvious from the context which elements we're skipping over. So here in this example, we're skipping over the numbers from 4 to 97. Now we want to say whether or not an element is in the set or not in the set. So we use this pitchfork symbol to say is an element of. So for example, The Dark Knight is an element of our set B, the set of Christian Bale Batman movies. Conversely, if we want to say is not an element of, all we do is just put a diagonal line through the pitchfork symbol. So here we're saying that Batman and Robin is not a member of our set B because Batman and Robin stars George Clooney and not Christian Bale, so it's not a member of our set. Now this is one of the most important concepts to understand. It's so important it even has a name. The name is the axiom of extension. So what is that? Basically, all the axiom of extension is saying is that sets that have the same members are equivalent. So basically what this is saying is that a set is totally defined by its members and nothing else. Not, for example, the orders that the members appear in, not the time you created it, not the name you gave it, nothing else. So, for example, let's look at this Python script here. So we're making 2 sets, A and B. Here we create the set A and then we put the numbers 1 and 2 into set A. Here we create the set B and put the numbers 1 and 2 into set B. And here we're just testing whether A and B are the same set or not. So because they contain the same members, namely 1 and 2, they are indeed the same set. So A equals B is indeed true. So if a set is defined only by the elements it contains and nothing else, that means the order of the elements doesn't matter. So for example, here is the set of the films by the famous director Christopher Nolan. And you can see we can put this set in any order. We can order the films by their release date, or by their title, or by their average rating by users. But whichever way we order them, it's still the same set. That's because order doesn't matter when we're talking about sets. So a handy way to remember this is that the set containing A and B is the same set as the set containing B and A. So going back to our Python script, we can see that if we reverse the order of the elements that we put in B, but leave the ones in A as is, we still get the same result. The 2 sets are the same regardless of the order that we put the elements in. Another really important consequence of the axiom of extension is that it doesn't matter if we put the same element in as many times as we like. It still only counts as one element. That's because repeats don't matter when we're talking about sets. This set containing 5 instances of The Dark Knight is the same as the set just containing 1 instance. So a good way to remember this is the set containing A is the same as the set containing A and A. So looking at the Python, again, let's keep A the same, but this time we'll add the number 2 a bunch more times to the set B. The sets are still equivalent. It doesn't matter that we added 2 this many more times because repeats don't count when we're talking about sets. So a lot of the time, students confuse the set containing an element with the element itself. The set containing the movie Inception is crucially different from the movie Inception itself. So a good way to remember this is that A does not equal the set containing A. Looking at the Python, let's say that the set A just contains the number 1. Instead of defining B as a set this time, we'll define it as the number 1. And you can see that when we test whether A equals B or not, the answer is of course false because the set containing 1 is different from the number 1. Those are some rules to get you started, and let's look at an example problem with those rules in mind. So for any integer n, let S of n equal the set containing n and negative n. So here 1 is serving as our n, so we need to copy this pattern here, but with 1. So S of 1 would equal the set containing 1, and then the second one is the negation of the number, so the negative number multiplied by -1. Okay, let's look at the next one. So our next one is S of -2. The first element we put in is just n, which is -2. The second one would be the negative of -2, which would be +2. And the last one would be S of 0. Again, we put n in, so n is 0, and then we put -n. So there's actually no such thing as -0, so we would just put 0 in again. But okay, we know that repeats don't count, repeats don't add anything to an unordered set, so this would just be the same thing as just a set containing 0 on its own. So the set roster notation is not the only system for writing down sets. Once we start talking about sets of numbers, then we get into the world of intervals and the number line and all that fun stuff. So click this video if you want to learn more about that topic. So that's about it from me. All this talk about those Christian Bale Batman movies has got me in the mood to go watch one of them. So I'm going to go do that. In the meantime, it really helped me out if you could like the video, press subscribe, and I will see you next time. Bye everybody.